just to kind of review a little bit where we were, just because we stopped in kind of a funny place last time. We were talking about C strings. Oh, someone asked me, I totally forgot. Someone asked me at the beginning to just show how to, I can't remember the word that you use, signify or indicate a C string. And basically a C string is just any array of characters can be used syntactically as a C string. So if I just say, char C star 1, 40, whatever, there I have a C string, okay, syntactically speaking. So for example, with C strings, you can use the extraction operator to read a C string. So I could say cout, enter your name, cn, C star 1. And that would be syntactically correct. All I need is an array of characters. The one caveat I would say is in order to use the C string functionality, you also have to have a null character in there somewhere, right? So for example, if I were to say, let's do this a different way. If I were to say C star 1 sub 0 gets D, and then I were to say cout C star 1, that could potentially be a problem because there may not be a null character in there, and so I may try to print a bunch of garbage or something. So if I really want this to be the C string, if I'm really expecting this to be a C string that has just one character, the character D, then I would need to put a null character in the next position. Okay, that would make it a C string that I could then use with the insertion operator. I could do strlen on it. I could do strcopy. I could do strcat. All those. Without the null character, I can't do all of that stuff. So since I've got this typed up, let's just take a first spin. Okay, there's my D. If I take this out, then basically what's going to happen is undefined, right? The C++ standard is going to say, if you try to do this, that's an error, and the results are undefined, which means it could work. We could get lucky and it could work, or it may crash your program, who knows? So just to try it out, it worked, okay? Just apparently by coincidence, or maybe because we just ran the program and did this, and it's still sitting there in that same memory location. It's working because there's, by coincidence, is a null character there next to the D. Any questions about any of that? I'm glad we asked that question. That would give us a chance to just kind of back up a little bit, talk about C strings again. Let me just say that this would not be the normal way of using a C string, like manually putting each character in there. For example, theoretically, I could say C star 1 sub 1 gets A, C star 1 sub 2 gets B, C star 1 sub 3 gets E. Okay, and then I would want to say C star 1 sub 4 gets null character, but I just want to see what happens if we try it without. Okay. So please stop me if you're not sure what's going on here. Part of what I'm doing is I'm just throwing up a bunch of stuff to see if it makes sense. And if something doesn't make sense, you know that you need to follow up on it. Still looks good. It seems. So my guess is that we just have a bunch of zeros sitting there in memory already. And so we're getting lucky and it's working. But to really do it correctly, I would then want to say this, right? Okay. All that to say, this would not obviously be the normal way that you would want to fill up a C string. Normally, you would say something like, I can just initialize it when I declare. Okay, and then that avoids the need for all of that. It automatically puts the null character at the end. And so I've got the same thing. Okay, questions about any of that? Okay, so we were talking about C string functions. The section in the textbook, the title of the section we're on is Library Functions for Working with C Strings. We talked about the strlen function on Monday, at least we should have. So if I do that, that's going to give me 4, right? Whoops, or not. Oh, geez. Spacing out here. Let me try that again. Okay, there's my Dave and my 4. Then we talked about stir cat last time. That's going to be a little more complicated to get an example going, but let's do C stir 2, 40. It's hardened. Then I could say stir cat. Cat is short for concatenation, which is just what we call it when we combine strings together. I'm going to put the target C string as the first argument, and then the one we're adding on as the second argument. And then if I print out C stir 2, hopefully that'll be Dave Harden, right? Or not. Let's see, what did I do? Oh, I didn't ever.
C1.
Sorry, I missed that. Oh, I want C stir 1, thank you. Yeah. And I also want a semicolon. Okay. The tricky thing here is, here's the most probably the, here's a really important sentence. Okay, I was going to try to say something about just how important, but I'm going to just go with, here's an important sentence. Every time you use stircat, you need to think about this sentence before you use it. You have to make sure that C stir 1 has been allocated to be big enough to store the result of concatenating these two strings. Okay, so if I just said, if I just made these as big as I need them, 5 and 7, right? Then when I do stir cat, what's going to happen is I'm going to be overflowing this array, and who knows what's going to happen with those characters that are being written into some other area of memory that I'm not supposed to be touching, right? Honestly, if I had to guess, I'd guess this will probably work anyway, right? We got lucky, but in general, There's no guarantees that that's going to work. And frequently, in any sort of a slightly more complex situation, you're going to end up with all sorts of weird memory errors being printed that you're not going to understand. So just be super careful about that. Any questions about struct? Oh, go ahead.
So let's say that the C*1 has a length of 20, and
Okay.
let's say they both have a length of 20. Would that cause and then you ran the program, would that cause an error because
So there's no, I don't mean to interrupt, but just in case this answers your question, there's no issue with having too much memory allocated, right? That's not a problem. Well, I mean, unless you're going to run out of memory or something, but in terms of getting an error, in terms of getting a memory error, there's no problem having too much memory allocated for those. So this would be perfectly fine.
What if the second string is larger than the first one, but the part of it that has been allocated isn't?
So I mean, I think you mean the part of it that is actually contains the C string.
Yeah, that's what I meant.
Right. So, you know, if this was 200, that's fine. Doesn't matter because all you're doing is you're copying these 6 characters into C*1.
Okay, I got it.
Okay, no, good question. Anyone else? Okay, and so strcat basically, you could think of it as taking the place of a plus equals operator, right? This is essentially what we are saying when we use strcat. The other thing is that technically speaking, if you go, if you go online, you Google it, whatever, and you study strcat, it's going to tell you that it actually returns a value. It returns the result. But in practice, the best thing to do is to actually just treat it as if it was a void function. Okay. All right. So if there's no other questions about strcat, let's talk about struct copy. I always thought it was a little strange that he covers strcat before covering struct copy, because struct copy is basically like a simpler version of strcat. But if I do this, that's simply like an assignment operator, right? It's saying replace what's in C*1 with what's in C*2 instead of adding it to the end of C*1. So in this case, I would be going back to C*1 is going to just get equal to harden, right? Let's see. Whoa. I'm looking for my terminal. All right. Any questions about what just happened with that last one? Okay, so strlen and strcat and strcopy, you are going to become experts on those 3 functions in about 3 or 4 weeks. So those are really important to get. Going through the textbook, the next couple are strincat andstrincopy. And the basic idea behind these two So these two functions we are not going to use in this class, but you do need to know about them just so that you know about them for down the road sometime. Basically, they are an attempt to make strcat and strcopy safer. So they take 3 arguments instead of 2. And the third argument just says, here's the maximum number of characters that you can copy over. Okay. I'm not going to talk any more about those, but I do want to just use the opportunity to mention, because I can't remember how much I talked about this on Monday, that generally speaking, strcopy and strcat are not considered safe. They're considered sort of risky functions to use. If you're programming in the real world and you have to deal with strings, I would certainly say don't use C strings, which may force you to use strcopy and strcat. Instead, use the string object. The only exception to that is if you're in a situation where, you know, every bit of memory matters and every billionth of a second matters. In that case, you may be forced to work with C strings. Or if you're dealing with code that is legacy code that is already built on C strings, something like that. But if you have a choice, you're always going to want to avoid these. Now, Visual Studio actually is so serious about this that it will not let you compile code that has strcopy and strcat by default. So in order to compile and run your program that uses strcopy or strcat, you're going to have to put sort of a magic code at the top of your file. And so when we get to that assignment, that will be in the assignment. I'll say, oh, don't forget, if you're using Visual Studio, you need to put this line of code at the top of your file so you can use strcopy and strcat. Okay, no questions about that? And if you look online and read through some of the forums, there's going to be arguments or debates about whether str-in-copy and str-in-cat are really any more safe than just using strcopy and strcat. In either case, it's up to the programmer to make sure that you don't overflow the memory that you've allocated. And so in either case, you'd like to avoid using them if you can. So anyway, we're just going to be sticking with strcopy and strcat. The next function that is mentioned in the textbook is a function called stir, and I'm not going to talk about that at all. We're not going to use it in any of our programs. It's possible you may see it on a multiple choice exam. So I guess the main thing is just know where it is in case you need to look it up. Finally, I think this is the last one. Yeah, so the last C string function that we're going to talk about, and this is another one of the ones that you actually definitely need to know about, is stir compare. Okay, stir compare is just the way that you're going to have to compare C strings, because you can't use operators like equal to, less than, greater than, not equal to, and so on. So instead of just simply using the relational operators to compare two C strings, you're going to have to use this stir compare function. There's a question in the chat asking more about what str-in-cat and str-in-copy do. And basically, I'm sort of intentionally not going into too much detail on that. But I will tell you that, well, like I mentioned, they take a third argument, and the third argument just gives a maximum number of characters that can be copied over. Okay, so it's a way of preventing too many characters from being transferred over and causing an overflow error. Okay, so the way stir compare works is, let's say I wanted to say something like if C stir 1 is less than C stir 2, which when we talk about less than and greater than in terms of strings, and when I say strings in that sentence, I mean just the abstract concept of a string in any programming language. We're talking about alphabetical order, right? So if C stir 1 comes before C stir 2 in the dictionary, essentially, whatever a dictionary is, right? You have to imagine that, it's the old days and you actually have like a book on your desk that you record that in. So we cannot do this using C strings. So instead what we do stir compare C stir 1, C stir 2, if it's less than 0. If stir compare returns a number less than 0, that means that its first argument was less than its second argument. Okay, so just a little more complicated way of asking that question. Okay, so all right, and if stir compare returns 0, that means that the two strings are equal. So I could say if stir compare C stir 1, C stir 2 is equal to 0, that means that they're equal. So I could say something like C out C stir 1 equals C stir 2. Okay. The other thing that I haven't mentioned, sort of a technical point, sorry, this is totally a digression, but I should probably have included C string up here at the top. Anytime I'm going to be using stir copy, stir compare, stir cat, stir len. All right, let's just try this out. Is stir compare the difference between two C strings? That's an interesting question. The answer is no. Stir compare just is defined to return a negative number if C stir 1 is less than C stir 2, a positive number if C stir 1 is greater than C stir 2, and 0 if they're equal. One way to implement that might be to just subtract them, right? Subtract the values. And that might actually be the implementation in some systems, but you can't assume that. There's no guarantees about whether that's going to be the implementation or not. Did that answer the question? I guess the short answer is no. Okay. Okay, so we're going to just try this out. Too many, probably too many. Okay, so C stir 1 and C stir 2 are both hardened at this point, so they're equal. All right. Any questions about any of those C string functions? Okay. All right, so I'm just going to tell you now that the next section in the textbook is about converting between strings and numbers. We are not going to need to do that in this class. So it's there in the text. You might want to just read through it quickly. It's mostly just a list of different functions you can use. So you just need to know that they're there so you can go back and look at it in more detail if it ever turns out that you do need something like that. So that's section 10.4. 10.5, what is 10.5? No, I think that I got that mixed up. That was 10.5. So 10.6 is writing your own C string handling functions. I'm not going to go into that. You probably want to look that over. It's basically what you're going to be doing in assignment 6. In assignment 6, I'm going to say, okay, here are some functions to write that take C string arguments and perform some sort of operation on those C strings. You're going to have to write those functions sort of from scratch without using anything like strcpy or strcat, or I think I actually allow you to use strlen, but anyway. So you're going to be writing your own low-level C string handling functions. But there's really nothing new in section 10.6. It's just a couple of examples of showing you how to use the stuff that we've just been talking about. So I want to just spend a couple minutes talking about 10.7. Let me get the textbook up here. Okay, so more about the C++ string class. So far in this chapter, we've talked about characters and we've talked quite a bit about C strings. So now we're shifting gears to the third topic of the chapter, which is the C++ string class. So I'm just gonna, a lot of this stuff we've already talked about. We've talked about if you're going to use the string class, you have to pound sign include string at the top. We've talked about you can declare a string variable. You can use the assignment operator to assign a string variable. You can print a string variable using the insertion operator. So here's a string object. I'm just scrolling down to find what the next new thing. Okay, reading a line of input into a string object. This is probably something we should make sure that we get. Basically, if you want to read just a word, in other words, if you're okay with the input stopping when you get to a white space character, then just use the extraction operator, right? Did we do that up here? I guess there's no examples of, oh, right here, cin name, right? Just use the extraction operator and that's gonna read something from the keyboard and put it into the string variable name. But that only works if you're okay with only one word strings, right? If I were to type Dave Harden for my name, in this case, name would just end up being equal to Dave. Everyone clear on that? That's true for using the extraction operator to read C strings or using the extraction operator to read string objects. Either way, the extraction operator always stops when it hits a space. So what we're talking about now is, what if I don't want to stop when I hit a space? What if I want to read the whole line until I get to a new line character? That's when I use the getLine function. Same rule as we had when we were talking about C strings, right? If I'm using C strings and I want to read a whole line of input, including spaces, I use the getLine function. However, the syntax here is really different. In the other examples of the getLine function, we had something like cn dot getLine. Here, and in that syntax, and let me put that up there. So if I say, I think I'm going to just get rid of that. If I say cn.getLine cstr1, and then with that getLine, I have to give it a number as the second argument. So I'll say like 10. And that's what that means is keep reading until either you get a new line character or you've read 10 characters, whichever comes first. Okay. We talked about this, right? We talked about this on Monday.
Yeah, we did.
Okay. So getting my, that's the problem with teaching two sections of the same thing. Okay, so for example, then I could say cout cstr1, and if I have I type hi, my name is Hal. Look at that. Hi, my name. Why did it stop at NA? Because I told it to stop reading after it's read 10 characters, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it actually turns out to be 9 because the 10 actually actually includes the null character. Okay. Any questions about what just happened? Okay. So that's just a little bit of review so that we've got this up here and I can contrast this with our new version. If I have a string class object, and then I would want to say getLine, then the cn goes inside the parentheses. I don't have to give it a number because a string doesn't have a limit on how many characters it can hold. But I do need to tell it where to put what it reads. Okay, so now I'm going to say hi, my name is Hal. Let's see what happened. Did I not save? Oh. Oh, I know. Okay. Let's just make this bigger. Hi, my name is Hal. Okay, now it's waiting for me to type something else. So I'm going to say, hi, my name is Hal again. And it just prints that back up. Okay, so all of that is kind of a long way around of showing you how the getLine function works for reading string objects. Any questions about that? Okay, I do want to throw one other piece of information out there. And that is, I have introduced these functions as functions that read up until they get to a new line character. It turns out that that is their default behavior, but I can specify the delimiting character if I want it to be something other than new line. So if I want to read up until I get to the first colon, for example, I can just do that. And both of these, same thing on both of these. It's just an additional argument. So now I've got code that reads up until it gets to the next colon. Okay, that's just a little piece of trivia in case you ever need it. We will do this in our in an example in class in a couple of weeks or so. Pretty sure you won't have to do this in your assignments, if I remember correctly. Okay, I'm going back to the textbook unless there are any questions. So comparing and sorting string objects, really the only thing that you need to know about this is simply that you can use these relational operators on string objects, even though you could not use them on C string objects. Okay, so that's just very handy. An excellent reason to use the string class instead of using C strings. The rest is just, an example of sorting strings. So here's a list of different ways that you can initialize string objects when you declare them. Some of them are pretty, you get the default, so there's no initialization. Here, you're initializing name to a string literal. Here, you're initializing the string to another string object. And then you get into these more sort of fancy ones where you can, for example, this one defines an object which is initialized to the first 5 characters in stir2. Those are pretty obscure, I would say. I've never used anything like this. I wouldn't expect you to in this class, but here they are. You know where to find them now in case you ever want to do anything like this. Next thing is, here is a list of all of the operators that you can use with string objects. And it's interesting to compare this with C strings, right? So extraction operator and insertion operator, we can use those with C strings too. It's a little tricky, especially the extraction operator, right? Because we have to be super, super careful to make sure that when we use the extraction operator with a C string on the right side, that C string has been allocated to be big enough for whatever input the user types, right? But anyway, these are defined for C strings. The assignment operator is definitely not defined for C strings. Same with plus equals, same with plus, same with the relational operators. All of those, if you're using C strings, there's some other technique, right? In fact, let's go over that. If you want to use assignment for C strings, you would have to use the stir copy function, right? If you want to use plus equals for C strings, you'd have to use the stir cat function. Same with the plus, you'd have to use stir cat in a slightly different way. And if you want to use any of these relational operators on C strings, you can't. You would have to instead use the stir compare function. Okay, but all of these are available to use if you're using string objects. And I think that's pretty much all I want to say about strings. The last thing here is just this big long list of other string class member functions. There are a bunch of them. Even this table here that I'm going to get down to eventually seems like there's a ton of them, but even this is just a small subset of all the different member functions there are that you can call on my string objects. Don't feel overwhelmed. I don't expect you to know all these. Just know where to find the string class member functions if you need to look them up sometime. The only ones we've looked at length, right? Yeah, we looked at length and we looked at subster. So I would think you'd probably want to be familiar with those two. The rest I wouldn't worry about, just know where they are in case you ever have to look them up. Okay. All right, anything else you want to talk about with strings? I'm done talking about this chapter unless there are any questions. Okay, we're ready to change gears here a little bit. I need to just take a 2-minute break, so I'll see you in about 2 minutes. Okay, so what we're going to talk about now, our next topic, is the topic of structs. Okay, struct is a keyword in C++. And basically, just to give you the 30,000 foot view, a struct is just a way to combine a bunch of individual variables into one variable. You've done that in Python, I assume, using classes. The main difference is that in C++, there's this thing called a struct that is way less sophisticated than that. And it's the way that structs are used in C++ is you just have data that a bunch of individual variables combined into one. There's nothing more complex about it than that, the way that there is with classes in Python. And then we're also going to talk about a separate thing called a class in C++, which gives us some of the more sophisticated stuff. So a struct is basically just a super simplified version of a class. I just have to say I'm simplifying that distinction a little bit here. I don't want to go into a lot more detail yet, but if you're fact checking me, everything I just said is not 100% true, but we're going to go with it for now. For example, let's say that we have a program where we want to store information about people. And let's say for each person, we're going to store their first name. We're going to store their last name. We're going to store an ID number. We're going to store an age. We're going to store a street address. We're going to store a zip code. And this is the strange one, but bear with me. We're going to store a dietary restriction. Okay, we're going to, for each person, we're going to store either vegan, sorry, I can't remember what the other one is, gluten-free or no. Okay, so you can imagine that if we've got a complex program, maybe we're storing, information on 100 people, we probably don't want to have 7 separate variables for each person. It would be nice if we could combine all of these into a single variable that stores all of this information for a single person. All right, so that's sort of where we're going with this. I'm actually going to write a program that is going to read information about a bunch of people from a file. And then our program that we're going to write is going to be very simple. It's just going to read that information in and then print it back out again. But you can imagine that we might make this much more complex by allowing the user to do things like maybe tell me, give me a list of all the people who are older than 65, or please give me the information on this person with this ID number, or give the user a way to add a person to the list, or a way to delete a person from the list. Lots of things we could do with this. We're just going to keep it simple. We're going to read in the names, store them in an array, print them back out again. Sorry, Let me rephrase that, not just the names. We're going to read in the people, store the people in an array, and then print them back out again. Okay, that's the preview. One other thing I need to just mention by way of introduction, and that is that for this, we are also going to be studying how to read information from a file in C++. That's not something that we have talked about in detail yet. I thought about actually doing that separately, you know, like having maybe a 30-minute section where I just talk about reading from a file and then doing this example. I decided that I think it'll actually make more sense to actually learn about that stuff in the context of this problem, but it may feel a little bit like we're learning two things at once. So just to kind of give you a heads up about that, I'll try to keep those as separate as I can. All right, so let me show you the file that we are going to be reading. So here's the file. Each line is a single person, an ID number, a dietary restriction, a last name, a first name, an age, a street, and a zip code. So just want to show you that these particular people all happen to be famous people. So I'm actually, in my program, I'm going to be calling the type famous person as opposed to just calling a person. But everything else would just be the same if they weren't famous people. And of course, this is imaginary information about famous people. Okay, so first thing we need to do is create this struct. And so let me tell you what we're doing now is we are creating a new type that we can use just the same way that we could use any other type. And this is something that, you know, every time I teach this, it seems like I end up having to say this about 20 times before it starts to kick in. And that's okay, I can say it 20 times. But what you need to understand is that I'm creating a new type. I'm going to call that type famous person. Once I've got this new type, I can do anything with that type that I could do with other types. I can declare a new variable. I can use it in a parameter list. I can use it as a return type in a function. Wherever I would normally use the word int, I can now use the word whatever I called the new type. So here goes. Okay, so I'm doing this above int main because this is going to be an identifier. Famous person is going to be a word that we can use anywhere in the file. Inside these curly braces, I'm just going to list all of the different variables that we are combining into one big variable. So string last name, string first name. I think I have ID as an int, but int ID, char diet, int age, string street, string zip code. Okay, so what this means now is that if I declare a variable here of type famous person, then that person, that one variable actually now has 7 parts. So I could say something like, for example, person 1 dot age gets 37, right? Or person 1 dot first name gets Martha. Okay. Anybody want to propose a question at this point? One other piece of syntactic information here that's super, super important. If you forget this, you end up with error messages that make no sense. So it's best to just remember to get this right the first time. And that is a struct definition has a semicolon after it. Okay. All right, so notice that I'm not actually creating a variable here, right? There's no memory being allocated in the computer at this point. I'm just defining a new type so that later on in the program, I can declare variables of that type. So at this point, at line 25, at that point, now I'm actually allocating memory in the computer for this variable of type famous person. Can you nest structs into a struct? Yes, you can. Can you add functions to a struct similar to a class? Yes, you can. That's not typically how C++ programmers use a struct, though. If you're going to do that, you're probably going to just use a class instead. So basically, in C++, the convention is I'm just going to use a struct in a case where I don't need the full-blown functionality of a class. I just need a very simple, quick and dirty way to combine some individual variables into one big one. Honestly, there are many C++ programmers who would say, if you're programming in C++, you shouldn't use structs at all. You should always just use a class. I don't feel strongly one way or another about that, but we are going to be using struct in some very limited cases. And I thought that you should at least learn about it. Did I miss anything here? No, okay. Any other questions so far? Just kind of getting started here. All right, so let's go ahead and work on our actual program that we're trying to write here. The first thing I'm going to need is I'm going to need an array of these things, right? I've got something like 50 of these people in my file, and in my program, I want to make it flexible enough probably so they're going to have far more than that. So I need an array where each element of the array is a variable of type famous person. So the way that you declare, so I guess what I'm about to try to emphasize is that in defining this array, I'm not doing anything new that you don't already know how to do, right? You know how to define an array. If you know how to define an array of ints, then you know how to define an array of famous persons. It's exactly the same thing. You just use the word famous person where you would have used the word int before, right? So if I wanted to declare an array of ints, let me get a constant going here. If I wanted to declare an array of ints, I would say int my array size, right? So basically what I'm doing here is exactly the same thing, except I don't want an array of ints. I want an array where each element is a famous person. So I just say, oops, famous person here instead of int. And then I'm going to give it a little bit of a better name. I'm going to call it person list. Any questions about that array declaration? Okay, so now we've got our array. Basically what I'm going to do is I'm going to say, I'm going to have a function called read data. And I'm going to have a function called print data. And that's it. So as soon as we finish writing those two functions, we will be done with our program. So let's go down and look at read data. Okay, so let's talk about what's going to have to go on as far as communication here goes. Anybody want to tell me anything about what's going to go here in the parameter list for read data?
The name of the file
The
that
name
you're
of-
opening?
So that's an interesting question. You know, I could have set it up so that main has to tell read data the name of the file. But I think what I'm going to do is I'm just going to have read data be the function that already knows that. So somewhere inside read data, I'm going to have the name of the file hard coded in there. All right. For better or for worse, that's what we're doing.
Question.
Yes.
If you put the struct definition below the main function, can you put a prototype for a struct?
You can do, you should, I wouldn't recommend that. I think you could do, you know, I don't know the answer to that. We could try it, but I've never tried. The convention would be to just have the struct definition above main. So if we get a little further along here and you want me to just try that out to see if it works, feel free to remind me.
Okay.
Okay, so I think the correct answer here is that we're going to be communicating back and forth between read data and main about this variable right here called person list, right? Read data's job is to fill up the person list with the information that it gets from the file. So I'm going to put a parameter here for person list. In terms of the syntax for that, I want to be clear that you already know everything you need to know to get that right. One of my favorite sentences of the semester you may have heard me say before is a parameter is a declaration, right? So what's going to go here is I'm saying, okay, I need a parameter that's going to be an array of famous person. So what goes here is simply a declaration of an array of famous person. So essentially exactly the same thing I have here, right? Except with one caveat, right? Anyone want to tell me what the one thing that changes is?
No
Take out array
semicolon.
size?
Right, we don't need to put anything inside the square brackets. Now, just to, as a side point, this would still compile and run fine. It's just that the compiler ignores what's in here, so we might as well just take it out. Okay. So there's my parameter. Any questions about how we did that? Okay. What about, should this be passed by reference or should it be passed by value? Or let me ask that a different way, okay? Do I want an ampersand there?
Is it going to be changing anything in the file?
Okay, well, a great question. First, I'm sorry, I'm thinking about which angle on that to answer first. I guess my first point would be it's not about the file, right? It's about this array. So the question should be, is read data going to be changing this array? And if it is, do we want that change to be reflected back out here in main? The answer is yes, right? That's the whole point of read data. The read data function is supposed to modify this variable by filling it up with the names from the file. So we do want this to be passed by reference. Let me say that one other way. Okay, we want it to be passed by reference because this is information that is flowing from the called function back to the calling function. But as someone in the chat pointed out, because it's an array, it's already automatically passed by reference. So I don't need the ampersand. Okay. All right, so I basically just did a review of stuff from the lesson on arrays. If any of that, well, actually, I guess a lot of what we just talked about was in a review of arrays, but also a review of pass by reference and pass by value, which is going back to lesson 6. If any of that is still unclear, I just want to put it out there that that's pretty critical that you get that pinned down, get it nailed down. You know, you've probably heard me say several times when we've been talking about something, I've said maybe, you know, this is the first time we've seen this. If it's not crystal clear right now, that's okay. We're going to be coming back around to it a few times. This is not one of those times, right? At this point in the course, if you're a little fuzzy on pass by reference and pass by value, you really want to get that nailed down as soon as you can. So feel free to ask right now or anytime during lecture if there's something about that that is still a little fuzzy. And I just looked at the clock and realized that we're just about out of time, but I guess I just want to say this is correct now. And then we have to put the argument here. Again, we already know the rule for this. When we want to pass an array as an argument, we do the same thing that we do with any other type that we want to pass as an argument. And that is, we simply put the name of the array, person list. Okay. Lots of review going on here. That's okay. That's good. All right. So I think we're going to have to stop there. So on Monday, we'll wrap this up. We will be going over how to read from a file on Monday, and we'll be going over the rest of just how to get the information into the array of structs and then print it back out again. Anything else that we need to talk about before we go? All right, have fun in lab, and I will see you on Monday.
Thank you.